Okay, so in this video, I'm going to explain about exponent rules. So the first thing that you need to understand is that we have an index form, a general index form, which is this one over here, okay? So if you see something like that, we have like this guy and then n to the power of this guy. We have that a, we call it the base, and the n, we call it the index. So I'm going to use a lot of that word later, okay? Okay, so the next thing that I would like you to understand is that we have all of these. Actually, we can apply that to numbers, but because we're talking about algebra, so we're going to use a variables. Okay, so the first one is we're going to talk about this product rule. Okay, so again, the first one is understanding what product rule is. We have a to the power of x times a to the power of y is equals to a to the power of x plus y. Okay, so the first thing that you need to understand that if you want to apply this rule, the base must be the same. So if I have like a to the, so if I have a to the power of 2 times a to the power of 3, I can just like add this 2 plus 3 equals to a to the power of 5, right? Because they have the same base. But if I have like a to the power of, let's say, 3 and then multiply by b to the power of 5, I cannot say this is ab to the power of 3 plus 5. No, this is not going to be working. And that's therefore, if I give you an example, let's say I have an example. Let's say I have a number, okay? The a is a number. Let's say I have 2. 2 to the power of 3 multiplied by 2 to the power of 2. Let's say like this. What do I get here? If I have this is equals to 2 to the power of 3 plus 2, right? Because you're just multiplying and it has the same exact base. And that's why we can just add them. So it's equals to 2 to the power of 3. Okay, let me give you a reason why this works. Okay, so if I calculate this guy over here, what do I get? I will get 2 to the power of 3, which is going to be 8, right? 2 times 2 times 2 is 8. And then you multiply that with 2 to the power of 2, right? 2 times 2 is 4, okay? 8 multiplied by 4 is 32, right? Okay, let's see whether this calculation is going to be the same with this one, right? Because we know that this is an equation. You need to write down equal sign. So we have 2 to the power of 5. So what does 2 to the power of 5 means? It means that you're multiplying 2 5 times, okay? 2 times 2 is 4. Times 2 again, you get 8. Times 2 again, you get 16. Times 2 again, you get 32. As you can see that, in both of the left hand side and the right hand side of the equal sign, it has the same value. So which means that we can apply these rules, okay? Okay, the next one is the quotient rule. So basically the same thing, guys. The same thing. And here we're multiplying, right? So keep notice that if you're multiplying, you're going to add the power, okay? But like I said before, there are some rules that you need to fulfill first. For example, like the base needs to be the same. If it's not the same, then you cannot do it. Okay, so the same thing. If I have, let's say I have another example. I have 2 to the power of 5 divided by 2 to the power of 3. Right? Because again, you need to check, the first thing that you need to do is to check whether the base is the same or not. We have this guy and this guy. Both of them are the same. Okay, so we agree that the base are the same, so we can do the quotient rule. So you only need to subtract the power. So we get 2 as a base, and then you subtract the power, which is 5 and 3. Right? So this guy minus this one. So we get 2 to the power of 2. Okay, so let me illustrate a little bit why this works. Okay, 2 to the power of 5 divided by 2 to the power of 3. Actually, I can write it down like this, right? It's a form of division. It's the same thing as fraction. So if I want to expand that, 2 to the power of 5 is actually like 2 times 2 times 2 times 2 times 2, right? We have 1, 2, 3, 4, 5. So multiplying 2 5 times. How about 2 to the power of 3? It's just by multiplying 2 3 times. Okay, so this is the fun part, guys. So if you see that all of them are multiplication, both on the numerator and the denominator, you can just cancel, right? It's the same thing like if I have like 10 over 15, right? You can just, I can just cancel this. You divide both of them by 5, right? You can divide by 5 becomes 2, and then this becomes 3, right? So basically you're doing the same thing, right? Actually, I can cancel this one. I can cancel this one. I can cancel this one, right? So it becomes 1, 1, 1, 1, 1, 1, right? So what do you leave here? 1 times 1 times 1 times 2 times 2, right? So we get 2 times 2. And then the denominator is just 1 times 1 times 1. It's just 1. Well, you don't really need to write it down. So we have 2 times 2. 2 times 2 can be written as 2 to the power of 2 because we're multiplying 2 twice. As you can see here, this is actually equals to 4, right? And then this is actually equals to 4. So that's why if we have a quotient, if we have dividing terms and which they have the same base, we can if it has an index, so you only need to subtract the index, right? So we can say that a to the power of n divided a to the power of m is equals to a to the power of n minus m. So you only need to subtract the power. Okay, so for the next one is what we call the power rule. Okay, so here we go, this power rule here. Right. So this rule in Exponent, we can apply it like this. Okay, so if I have, let's say I have a to the power of n, and then I have this bracket here, and then I power this index form to another power. We can simplify this by just multiplying the power. So it is a to the power of n times m. Okay, so an example of how this works. Let's say I have a number. Let's say I have 2 to the power of 3, and then I have another power to the power. Let's say it's 2. Okay. Okay, I'm gonna use other number, maybe like 4. Okay, so we can rewrite this and simplify this, or opening the bracket by just multiplying the power. So this is like 2 to the power of 3 times 4. Okay, you actually can use like a bracket, right? And then this is equals to 2 to the power of 12. Okay, so again, let me show you how this works. 2 to the power of 3 is actually like 2 times 2 times 2, right? This guy. And then you get to the power of 4. So what this index do is just like multiplying these 4 times, right? So if I need to like rewrite that, I have like 2 times 2 times 2 as the first slot, right? And then I multiply it again, like 2 times 2 times 2, right? Because this is 3 times. And I multiply it again by 2 times 2 times 2. And then the last one, I am multiplying like 2 times 2 times 2. So it's just like 4 lots of this, right? 4 lots of that. So using the product rule that we have discussed previously, because all of them have this are the same base, so you can just write that 2 to the power of how many 2's you're multiplying. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is 2 to the power of 12. So it's the same with this one. Okay, so this is the illustration why it works. So I'm gonna give you one more example for this power rule. Let's say I have 5 to the power of 6, and then to the power of, like, let's say it's 3. Okay, so we can write this down as 5 to the power of 6 multiplied by 3. This is equals to 5 to the power of 18. Okay, for the next rule, we have power of product rule. This one here, right? We have ab to the power of x is equal to a to the power of x, b to the power of x. I'm going to use n and m this time. So we have a to the a times b to the power of n. Let's say I'm using n. It doesn't really you can have any other any alphabets as long as you make it different with this two, right? To make it consistent, which one is the power and which one is the base. Okay, so for this over here, we can write this down as if we have like this power and then we have like a multiplication inside bracket. So actually it's like a distributive power. It's like you distribute this n and multiply it for each of the terms inside, I mean like the index power inside the bracket. Right, so we will have like a to the power of n times b to the power of n. So this n goes to each of the variables inside the bracket. Another thing that you need to understand that actually where do we get this n, because actually it has a power for a and b, which is 1, right? But we don't really need to write it down. In case you have different power except 1, let's say I have another example. Let's say I have a to the power of 3, and then I have b to the power of 4, and then I power this again with 2. Okay, so Actually, this is like the combination of power rule. So what this 2 does is just like you distribute this 2 to each of the index form inside the bracket, right? So because I can rewrite this as like a to the power of 3 and then 2 to the power of 2 and then b to the power of 4 to the power of 2. So each of this 2 index form, because they have different base, right? We can separate them and multiply this power outside the bracket to each of them. Okay, so we have 3 to the power of, so we'll get a to the power of 3 times 2 is 6, and then b to the power, so I forgot to write this one, b to the power of 4 to the power of 2 is a to the power of b to the power of 8. Okay, another example, if I have, let's say, like a coefficient, right? So I'm gonna write down here, we have 2, a to the power of 3, b to the power of 4, and then I powering that to the power, let's say it's 5. Okay, so in here, although this is not a variables, right, like a and b, but actually you do the same. I mean, like you consider that to be another form of index form. So actually this is 2 to the power of 1, right? You don't see the 1, but actually it's there. So what you need to do is to like put all of that to a to the power of 3 and b to the power of 4 like this, 2, and then a to the power of 3 and then b to the power of 4, and then give that 5, like put it in the power for each of them. So like, this is 5, this is 5, this is 5. Okay, so this guy goes here, and goes here. So instead of writing down this 2, this is 2 to the power of 5. So you don't need to like calculate this if you don't want to. I mean, like if the question is asking you for like to answer that in an index form, so you don't have to do anything with it. So 2 to the power of 5 is just 2 to the power of 5, and then a to the power of 3 to the power of 5 is a to the power of 15, because we know that 3 times 5 is 15. And the last one is the b, right? The b is to the power of 20, because we have 4 times 5 is equals to 20. So again, like I said before, guys, but if this calculation is quite easy, you can just write down, because you know that 2 to the power of 5 is 32, so you can write down 32, a to the power of 15, b to the power of 20. The next is the power of fraction rule. So before the previous one is product rule, right? Power of product rule. This is power of fraction rule. So basically it's almost the same thing, right? But the difference is that this is in fraction form or in division form. So if I have like a over b to the power of n, I can get a to the power of n over b to the power of n. So basically you just like distributing this power to each of the index form inside the bracket. So because this is like a quotient form, right? So like in fraction, so you put it like for each of them. So let's say I have another example like previous one. We have like a to the power of 3, let's say, and I have b to the power of 5, and then I power this again with 2. So it's quite easy, and it's the same, has the like very similar concept like the previous one. You only need to like distribute this 2 to each of the index form inside the bracket, right? So we'll get a to the power of 3 to the power of 2, and then we get b to the power of 5 to the power of 2, right? So that 2 over here is distributed to all of the terms inside, all of the index form inside the bracket. So you can do the power rule. Power is it? Yeah, the power rule, and just calculate this for easy, right? A to the power of 3 to the power of 2 is just a to the power of 6, because we know that 3 times 2 is equals to 6. The same thing, we have b to the power of 5 to the power of 2 is just b to the power of 10, because we know that 5 times 2 is equals to 10. Okay, so let's say we have another example. Let's say we have like a coefficient for like the variables. Let's say I have another 2. So I have 2 a to the power of 3 over, let's say, is 3 to the power of b to the power of 5, and I power that again with 2. Okay, so as I said before, so you can do it one by one. Like you can do the numerator first and then the denominator, just by using the concept that you have learned before in the power of product rule. Okay, so let's focus now on the numerator first. So if I have the numerator is like this, I'm gonna focus here, guys, right? So that one. So I can write down as Okay, so if I focus on the numerator, I will get 2 to the power of 2, and then a to the power of 3 to the power of 2, right? Focus on the numerator. So this guy, this 2, is distributed to here and to here, right? So this 2 to the power of 2, this 2 comes from here. Wait, guys. Why is that working? Okay, sorry guys. Okay, so you do the same thing with the denominator, right? So again, this 2 over here needs to be distributed to all of the things. What do you call it? Like the next form inside the bracket. So we have 3b to the 5. I can just separate that 3. I will get 3 and then to the power of 2 again, right? This 2 again is from here, and then I get b to the power of 5 and then to the power of 2. Okay, so when we have this, it's going to be easy because it's going to use the concept that we have learned before previously, which is just, okay, I can just like 2 to the power of 2. If this is a simple calculation, you can just like calculate that. We have 2 to the power of 2 is 4, and then a to the power of 3 to the power of 2 is a to the power of 6. We get the 6 from multiplying this 3 and 2. Okay, okay, so the next one is, wait, it's a bit laggy. Okay, so the next one is the denominator, right? So you do the same thing. 3 to the power of 2 is just 9, right? 3 times 3 is 9. And then that b to the power of 5 to the power of 2 is just b to the power of 10. What do I get? We get this 10 because we have this 5 and 2, and that is a product rule, is it? And power rule. And we just multiply. 5 times 2 equals to 10. So that is for the power of fraction rule. The next one is a zero exponent. This guy over here. Okay. In this rule, we have zero exponent, which is the index is 0. So I will get a to the, if a to the power of 0, you'll get equals to 1. Okay, so what does that mean? It means that a number to the power of 0 will be equals to 1. So let me show you why it works. Okay, remember in quotient rule, right? In quotient rule, you're dividing, and this guy over here, right? If you divide like two terms in which they have the same base in an index form, you only need to subtract the power. Okay, so let me go back to there. Let's say I have like 2 to the power of 5 over 2 to the power of 3. You will get 2 to the power of 5 minus 3, which is equal to 2 to the power of 2, right? So you only need to subtract this power over here. So how about this one over here? So let me give you an example. Let's say I have like 3 to the power of 5, right? And I want to divide that 3 to the power of 5 again. Okay, by using the quotient rule, you will get 3 to the power of 5 minus 5. You will get 3 to the power of 5 minus 5 is 0. And as you have known that if you have like the same number or the same value on the numerator and denominator, you can just like cancel it. Remember? Oh, this is 3 to the power of 5. This is also 3 to the power of 5. So I can divide both of them by 3 to the power of 5. I will get 1 over 1. 1 over 1 is equals to 1. So there we go. Why a to the power of 0 is going to be equals to 1. Okay. So let's say I have another example. Let's say I have like 1001 to the power of 0. This is also going to be 1 because we know that we can use this rule over here, right? So any number is the same thing like 1001. Let's say I have a power like 3 and then 1001 to the power of 3, right? So 3 minus 3 is equals to 0. So if I have this the same value for the numerator and denominator, I can select cancel, right? Equals to 1. Okay, but there is a problem. Okay, what if the a is 0? What if the a is 0? So if I have a, let's say I have a to 0, let's say the value of a, if a equals 0, that makes us can rewrite this equation, this term expression as 0 to the power of 0. So if you put this into calculator, you will get like math error, right? So this is actually undefined. Why the 0 doesn't work? Okay, let me give you an illustration. Let's say I have this like the same thing like the previous example like I gave you before, like 3 to the power of 5. divided by 3 to the power 5. You will get 3 to the power of 0, right? So 3 to the power 5 over 3 to the power 5. This is like just like 1 because 3 to the power 5 minus 5 is equals to 3 to the power of 0 equals to 1. I can have also like 3 times 3 times 3 times 3 times 3, right? 3 to the power 5, and then 3 times 3 times 3 times 3 times 3. I can like cancel, 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 cancel. I still get 1, right? But if the number is 0, if the base is 0, right? If the base is 0, so let's say I have 0 to the power of 5 divided by 0 to the power of 5. This, if you're using the quotient rule, you will get 0 to the power of 5 minus 5 equals to 0 to the power of 0. You will get 1. But there is a problem, okay? Why? Because we are dividing by 0. Okay, so if you still, if you know, if you remember, what if we divide any number with 0? What does that becomes? Maybe some of you say it will be 0, right? But there's a problem there again. So let me give you a concept that is quite easy to understand. Let's say I have 6 divided by 2. Okay, so 6 divided by 2 is equal to 3, right? It's very easy calculation. I can rearrange this and write it as 6 is equals to 3 times 2, right? Because remember algebra, you can like multiply both sides with something, right? And then you'll get the same result. And then this is like 6 equals to 6, right? So remember the left-hand side and right-hand side of the equal sign needs to have the same value because this is an equation. Okay, so far so good. This is okay. What if I have the denominator is equals to 0? So I'm going to use another color. We have 6 divided by 0. Okay, so 6 divided by 0, and your calculator said it's math error. But why is it math error? Okay, so maybe some of you say that, oh, this is equals to 0. Okay, but there's a problem. If I'm using this concept here, right? Will it work for 6 divided by 0 equals 0, right? So if I can't just like do it like that. I mean like if when I do this, actually I'm just like moving this 2 goes there, right? Because this is like a division, and in algebra we know that if you want to move one like number or to the other place, the operation needs to be like the opposite operation, right? The opposite operation. We can say that, oh, this is like a division and it goes there, it becomes a multiplication, right? So if I'm using that concept, this means, so I'm going to use a different color for the 0. This one, the 0 is here, the red one. This is the 0 with the purple one. So does that mean that 6 is equals to 0 times 0, right? Because I'm moving this 0 over here, right? So because this is a division, you will get a multiplication here. So when we do this, 6 is going to be equals to 0 because we know 0 times 0 is 0. But 6 it's not equals to 0. Okay? So that's why your computer or your calculator said it's math error. So actually it is undefined. So every time you divide anything by 0, you will get undefined number because there's no such number which fulfill this equation. Okay, so you can try to any number like maybe 0, but actually again divide by 0, it means that you're getting a math error, or we call it the undefined. Okay, so this is the basic concept why you cannot divide by 0. I mean like if you get divided by 0, you will get undefined. So instead of just writing down like in this form the 0 exponent, I'm gonna add some information in here. So the 0 exponent can be used if a is not equals to 0. Okay, if the base of a is not equal to 0. So if you have base of 0 to the power of 0, that is not going to be 1. It's going to be undefined. Okay. Okay, the next one is the negative exponent. This one over here. Okay. So if we have a negative exponent, the form of that base will be like a fraction, right? So if I have like a to the power of n minus n, right, this will be equals to 1 over a to the power of n. So notice that we only like changing the sign from negative into positive, right? So let me give you an example why this works. Okay, so let's say I have 2 to the power of 5 over 2 to the power of 6. Using the quotient rule that we have learned before, this is equals to 2 to the power of 5 minus 6, right? So you will get 2 to the power of minus 1, right? So this is just the power form. What if we do the like cancellation? Okay, so I'm gonna like expand this 2 to the power of 5, which is going to be 2 times 2 times 2 times 2 times 2. We're multiplying 5. We're multiplying 2 5 times, and then with the denominator we're multiplying 2 6 times. 2 times 2 times 2 times 2 times 2 times 2, right? You get this becomes this one, and this guy becomes this guy. Okay, so let's do the simplification by just like canceling, right? Remember that? Yeah, because all of them are multiplication, both the numerator, all of them are being multiplied, and the numerator also being multiplied, so you can just cancel, right? Okay, let's cancel one by one. I have 1, I have 2, I have 3, I have 4, I have 5, and I only leave this. Remember that it's actually 1, right? Actually, this is 1, 1, 1, 1, 1, 1, 1. So you'll get 1 times 1 times 1 times 1 times 1 equals to 1, and then 1 times 1 times 1 times 1 times 2 times 1 times 2 is equals to 2. You will get 1 over 2. So if I change this form into a negative exponent like this guy over here, I can rewrite that as, I'm going to separate one, like 1 over 2 to the power of 1. So let's see, pay attention on the power. Here this is minus 1, and here we have 1. You're only changing this sign. Negative become positive, positive becomes negative, right? So that is what you do. Okay, so let me give you another example for maybe a question from the exercise. Let's say I have like x to the power of 8, y to the power of 5, and then divided that by 8, x to the power of 10, and then y to the power of let's say 3. Okay, so using the concept that we have already learned, the first thing that you need to understand is, like, if you want to use this rules, the exponent rules, make sure that the base is the same. Okay, make sure that the base is the same. So when you want to simplify the x here, you have to find another x. Okay, whether it's on this numerator or in the denominator. In this case, it's the x on the denominator. So we're going to focus on here first, right? So what do we get here? We have x to the power of 8 minus 10, right? Because this is 8 and this is 10, and this is a division, quotient rule, so you just subtract the power. And then we get the next one here, this guy, right? 5 y to the power of 5, which is like 5, and then we have divided by y to the power of 3, so you only need to subtract. Okay, so you get x to the power of minus 2, y to the power of 2. So okay, right? So most of the time, the answer, the final answer, should be in a positive index, right? So yeah, this is also this is actually correct, but most of the time you will be needing the final answer in a positive number of index. I mean, like the index needs to be in positive number. So this is not positive, right? So how can we make that into positive number? Positive terms. Yeah, positive index. Sorry. If we use this concept here, right? This concept here, we can change that, right? We can write that down as 1 over x to the power of 2. Okay, do you see what I'm doing here is just like, I'm just like putting this and then changing that into positive term by putting it down here, right? So it's simple as that. And then the y doesn't change because it's not negative, so just like y squared. And then you can just multiply this, right? So remember in multiplying fraction, right? If I have like 2 over 3 times 5, right? This is going to be, I'm not good, so times 5. This is going to be just like 2 times 5, which is 10, and then this guy doesn't change. As simple as that. Okay, so it's the same thing here. So the 1 times this is like 1 times y squared is just y squared, right? It's just y squared. So you get equals to y squared over the x squared doesn't change. There we go. So actually you can simplify this again, but you don't really need to do that in this question. in this example. I can rewrite it like this, but yeah, this is correct. This is also correct. Okay, another example here, guys. What if I have a number? What if I have a number in front? If I want to write down, let's say I have 3x to the power of minus 2. Okay, the question is, does this becomes like this? Or is it becomes like this? Which one is correct? I guess? Okay, the correct one is this one. This one is not correct. Why? Because this 3, right, doesn't have any negative index, right? This 3 doesn't have any negative index, so you don't put it here, right? So you don't put it there. So you can do this as a separate, what they call it, separate terms. Let's say I have like, again, I'll rewrite again. So if I have this guy, like 3x to the power of minus 2, this as the same thing as 3 times 1 over x squared. Notice that the one that's changing is only this guy, which has this negative index, right? This 3 doesn't include to this minus 2 power, right? So the one is changing, I mean, like you only need to put the terms like the x to the power of minus 2. If you want to make it into a positive power, you only need to change that. You don't need to change the 3. So in the final, so we can just multiply this. So 3 times 1 is just 3, and then we have x to the power of 2 as the denominator. Okay, so this is going to be the truth. This one is incorrect. Okay, last but not least, the fractional exponent. This guy over here. Okay. So in this fractional exponent, we can write down exponent in index form. If the index is in a fractional form, you can write it down as a root form. Okay, so if I have like a to the power of n over m, I can write this down the root to the power of m, a to the power of n. So remember that this guy as the denominator should be in here. Okay, don't be swapped around. So if I have, let's say I have 4 to the power of 1 over 2. Okay, 4 to the power of 1 over 2, I can write it down as square root, right? Because this is to the power of 2, this is square root. This is 4 to the power of 1, right? So if I use a calculator, I will get just 2. So it's simple as that. Okay, let me give you another example. If I have, let's say, 2 to the power of 3, and then I have to the power of 2 over 3. Right, so if we use the what do you call it, the power rule, you can just like multiply this, right? It's quite easy, right? So you only need to multiply. You will get 2 to the power of 3 multiplied by 2 over 3. So you are multiplying these two powers, okay? So you will get, you can just cancel this 3, right? You will get 2 to the power of 2. This is going to be equals to 4. Okay, so now what if we use the what do you call it, the root form, the fractional form, into like a root form? If I have that same exact question like this, right? I'm gonna use other color maybe. Like the 2 is this one, and this is going to be 3. Okay, so this is going to be equals to, I'm gonna write down the base first, which is 2 to the power of 3 in this case, and then it will be like in root form, and then I will get the 3. So this 3 comes from here, okay? It's like the cube root of that. And then I have the 2, which is going to be here, this 2. Okay, so let's do the power rule first. So if I use the power rule, I will get, this is like normal. Okay, so I have root of, the cube root of 2 to the power of 3 to the power of 2 is just 2 to the power of 6, right? Because 3 times 2 is x. Okay, and then you can like just calculate this using the calculator, right? Or yeah, 2 to the power of 6 is like 2 times 2 times 2 times 2 times 2. You will get 64. Okay, I'm gonna write down that one. It has roots and 3, and this is 64. Okay, you can use a calculator actually, or you can use manual. A number, like you multiply the same number 3 times, you'll get 64. What is the number? It is going to be 4, right? Let me prove that. 4 times 4 equals to 16. If I multiply this with 4 again, I will get 64. What's 64?